Hey, Denell High School, this is Mr. Ayton, and this is the final vodcast for chemical reactions. This is the sum of all of our chemical reactions from the first week to the last week. And this encompasses all our chemical reactions. Make sure you can go on MrAyton.com and take a look at those chemical reactions, print them out so that you can practice them on your own. But I'm going to balance every single one and go through every single one for you right here. The first set that I'm going to go through is all of these combination reactions, okay? And they are also oxidation reduction reactions as well. The first one is hydrogen gases burned in air. So I get hydrogen gas. I'm going to add in air or oxygen gas, anything that we're going to combust or burn, and we're going to get water out of it. And I'm going to balance this guy, and in balancing it, I need two H2s, I need two H2Os, and that balances it perfectly. The next is we have solid sulfur. Solid sulfur is burned in oxygen gas, another combustion reaction. Also, it is an oxidation reduction reaction. And out of it, I'm going to get sulfur dioxide, SO2. Already balanced and done. The next one is we have solid magnesium, that's Mg. We're going to heat it with nitrogen gas. And from magnesium and nitrogen gas, we're going to get magnesium nitrate. We got to make sure we do our crisscross. We got Mg3 and 2. And we will have to balance this by putting a big 3 coefficient in front of the magnesium. The fourth reaction here, we have solid zinc, that's Zn, plus chlorine gas, that's Cl2. And we're going to get zinc chloride. We're going to get ZnCl2. And that's using the correct crisscross from zinc having a +2 charge and chlorine having a -1 charge. And the final reaction on this page is we have solid calcium, that's Ca. We're going to put in it oxygen gas, and anytime we put a metal and an oxygen gas, we get a metal oxide. We're going to get calcium oxide, CaO, +2, -2. And so to balance this, I need a 2 right there at the products, and I need a 2 for the calcium. That's our first set right here. Let's take a look at our second set. This is a lot of decomposition reactions. The first one is a very famous reaction. That's that hydrogen peroxide, that's H2O2, is going to decompose in bright light. Or if you put a catalyst with this, it will decompose even faster. This first order reaction is going to end up giving you H2O plus O2. And we need to balance this by putting a 2 in front of that H2O so that our oxygens end up becoming even. And we need a 2 in front of the H2O2. That's balanced. Second reaction is calcium carbonate. That's CaCO3, calcium carbonate. And when we heat up a metal carbonate, we get a metal oxide, calcium oxide, and carbon dioxide gas. And that's already balanced with 1 calcium, 1 carbon, and 3 oxygens. And the next reaction is solid potassium chlorate. That's KClO3. And that's going to heat up. This is the gummy bear experiment. And the KCl3 is going to break up into KCl, a metal chloride, and oxygen gas. And to balance this, I just need to make my oxygens the same number. So I'm going to put a 2 in front of the reactant, so 3 in front of the oxygen gas. And I need 2 potassium chlorides as well. The last reaction is we have solid ammonium carbonate. That's ammonium is NH4. And I need 2 of those because carbonate has a -2 charge. And when we break this guy down, it's going to break up into ammonia, of course. Carbon dioxide, you can see the carbon dioxide coming from that carbonate, and water is going to be left over. This is looks like a challenging one to balance, but it's pretty easy. We just put a 2 in front of the NH3, and we are totally balanced out. All right, this next set of reactions is we have metals adding to water, and we also have metal oxides adding to water. So let's start with this first one. We have sodium metal added to water, and anytime we put an alkali metal in water, we get a boom and we get a base. And so we're going to get sodium hydroxide as a base, but sodium hydroxide is strong, so I got to split him up into sodium ions and hydroxide ions. And what gives me my boom is my hydrogen gas. I do have to balance this because take a look at my hydrogens, they're off. So I need to put a 2 in front of that. I'm going to put a 2 in front of the water. And I will also, and is it done balancing? Yeah, no, I need to balance the charges as well, so I need to balance 2 in front of the Na plus and 2 in front of the Na. The next is we have calcium metal plus water, and I do get a little bit of a boom and a base as well, but this base is going to be a weak base, and so I have to keep that combined. It does not dissociate. We have calcium hydroxide and hydrogen gas right there. Okay? And this is not balanced. I need to put a 2 in front of this H2O And let's take a look. I have four hydrogens, and I have four hydrogens, two oxygens, one calcium, and I'm done. The next is we have solid potassium oxide, that's K2O, and we add it to water, H2O. And anytime we put a metal oxide in water, we get a base, but we get no boom. Okay, so we're going to get potassium hydroxide, but we need to split up potassium hydroxide. Why? Because it's a strong base and it dissociates 100%. I need to put a 2 in order to balance my K's out, and of course I got to balance my charges out as well by putting 2 hydroxides, and that will balance everything out. The next is we have calcium oxide, CaO is added to water, and again, metal oxide in water, I'm going to get a base, but no boom. Calcium hydroxide is weak, though, so I'm going to put calcium hydroxide together to be weak, and that's already balanced out. Let's take a look at my next set of reactions. Here we have non-metal oxides. So we have something like dinitrogen pentoxide is added to water. And if metal oxides in water give you bases, then non-metal oxides in water give you acids. Let's take a look at what type of acid comes out here. Looks like nitric acid. Nitric acid is strong, so I'm going to split that up. And I'm going to put a 2 right there, a 2 right there to balance out my charges, and let's see if that balances everything out. I have 2 hydrogens on each side. I have 6 oxygens on each side, 2 nitrogens, and my charges are balanced out. We have carbon dioxide is bubbled through water, CO2 is bubbled through water, and that's going to give me an acid. That's going to give me carbonic acid. That's found in my sodas, H2CO3, and I'm not going to split that up because it is weak. We have sulfur dioxide gas, that's SO2, is bubbled through water, H2O, and I'm going to get a acid. It might give you sulfuric acid. It's probably going to give you sulfurous acid, which is H2SO3. And why did we do that? It's a nice easy balance there. I don't need to do anything. My next set of reactions are acid-base reactions. So we got to make sure we keep in mind what is weak and what is strong. First we have potassium hydroxide. Potassium hydroxide is strong, so I'm just going to put hydroxide. Hydrochloric acid, strong, H+. What am I going to get? H2O. That's a neutralization reaction right there. Next reaction is we have acetic acid. Acetic acid is CH3COOH, or you could write HC2H3O2. Doesn't matter which way you write it, just matters that you can do it. It's added to sodium hydroxide, which is a strong base. Acids, Bronsted-Lowry acids, give away H+, which means you're going to get H2O. And what's going to be left over is my acetate ion, making sure to put the negative charge, which is my conjugate base right there. Next is we have ammonia and nitric acid. Nitric acid is strong. Ammonia is weak. NH3. The H+ gets given to the other side, and what do we end up getting is NH4+. We get the ammonium ion. Next thing we have is carbonic acid. That's H2CO3. And we have ammonia is NH3. Again, what do acids do? Bronsted-Lowry acids give away H+. So if it gives away an H+, what are we going to end up getting is HCO3 with a minus, and we're going to get our ammonium ion, NH4 with a plus. Let's take a look at the next set of reactions. The next set of reactions are still acids and bases. We have hydrochloric acid, that's H+, plus sodium bicarbonate. Sodium bicarbonate is NaHCO3, but it's a solution, so I'm just going to put HCO3 with a minus. Okay, if it was a solid, we would keep it together. And what are we going to end up getting is H2CO3. Or you could put H2O and CO2. It doesn't matter, because it's going to break down immediately. Both are correct answers. The next is we have dilute sulfuric acid, which is H+. We're going to put a solution of sodium fluoride, that's F-, and we're going to get the weak acid, HF. The next is we have hydrochloric acid, that's H+, as added to a solution of potassium sulfide, so we're going to get S-2, and we're going to get that stinky, rotten egg gas, that's H2S, and to balance that out, I need a 2 in front of that H+. The next is we have a solution of ammonium nitrate, that's ammonium. That nitrate is going to be a spectator ion, and we're going to add a strong base to it, that's OH-. And again, what's the NH4 going to do? Plus, it's going to give away an H+. We're going to get ammonia. You know what ammonia smells like? And H2O, which is water. Okay. The next set of reactions are precipitation reactions. Okay, so we got to figure out who our spectators are. This is when we have two solutions coming together. Who's our spectators in the first one? Of course, nitrate and sodium are our spectators. So we have calcium. We've got to make sure we put his charge, and sulfate with his charge, and we get calcium sulfate. Okay, already balanced. The next one, of course, nitrate and potassium are our spectator ions. So we're going to get silver, that's Ag+. We're going to get iodide with I-. Remember, we could have chloride here. We could have pretty much anything, any kind of halide, and we're going to get AgCl. The next is nitrate and potassium. Again, spectator ions. We're going to get lead with a +2. We're going to get phosphate with PO4 -3. And we got to do the crisscross here by doing Pb3, PO4 2, and we're going to put a 2 and a 3 to balance that out. We have ammonium sulfide and magnesium iodide. Ammonium and iodide are going to be my spectator ions here, which means we're going to get magnesium, which is going to be +2. And we're going to get sulfide, which is -2, and that gives us MgS, which is our precipitate, our solid. Our next set of reactions are redox reactions, or oxidation reduction reactions. Okay, and this is where we're going to get cadmium metal, that's Cd. Okay, that's right underneath zinc on your periodic chart. We're going to add it to copper +2. What's going to happen is Cd is going to get your charge, okay, not just because it's a +2 charge, but because it's in that family of zinc, it's going to be +2, and copper is going to be a solid piece of copper, already balanced. We have solid nickel, plus silver, that's Ag+, and nickel can be a bunch of different charges, but we're going to make nickel here, if we make it +1, it makes it nice and easy in order to balance, okay? If it's +2, if we put +2 here, that would just mean I would balance it like that. I can pretty much do it either way though. Here we have a bar of zinc is added to silver, that's Ag+, and zinc by itself is going to have a +2 charge. We're going to get little silver specks on this, and we're going to balance it by putting a 2 and a 2. The next is one of my favorite reactions. It's where I put zinc with a strong acid, H+, and I end up getting a zinc solution and hydrogen gas. Why do I like this? Because it blows up. Okay, and we just put a 2 in front of the H+ in order to balance it out. The next is we have zinc is immersed in a silver solution. Okay, and this, it looks exactly the same, doesn't it? Exactly the same as above. We're going to we get a little bit of silver solid, and we balance it out by putting 2 and 2. Remember, our atoms have to be balanced, our charges have to be balanced as well. And the last one on this page is we have chlorine gas is bubbled through a solution of a bromide solution, and that means bromine is going to come out, and a chloride solution will be, and I need to balance this by putting 2's in front of each of the halides here. Our second to last set of reactions are our combustion reactions. We have something like C2H4, ethene. Okay, they might ask you a question about his Lewis dot structure or something like that, or how many sigma or pi bonds, and it's going to be a combustion reaction, so we know it's going to be plus O2 gives me CO2 and H2O. I do have to balance this by putting a 2 in front of the carbon. I need to balance this by putting a 2 in front of the water to make 4 hydrogens, and then I add up my oxygens at the end. I have 6, so I need a 3 right there. Propane is C3H8. We should be able to know that formula either by knowledge or by drawing it out. Plus O2, it's burned, and we're going to get CO2 and H2O. This is a great formula because we use propane all the time. We need 3 carbons, of course. We need 4 waters to get 8. And add up my oxygens at the end. I have 6 from the carbon dioxide. I have 4 from the water, which is 10. So I need 5 times 2. It's 10. This is our last set. This is our complex ions. Okay, our first one is our Lewis acid base, where I have boron trichloride, BCl3, is added to ammonia, excess ammonia. And what's going to happen? They're going to come together to be BCl3 and H3. Okay, that's that Lewis acid, Lewis base reaction. Our next is we have excess hydrochloric acid with copper 2 chloride. Again, for complex ions, we're going to put our metal ion, which is called our metal ion, and we have our ligand, which is our Cl- here. And we're going to put copper with the chloride, and how many chlorides will I need? I'm going to multiply that charge on the metal ion by 2, so I need 4 chlorines, which means I need 4 chlorines at the beginning. I add up my charges at the beginning. I have plus 2, plus -4. That gives me a -2 overall charge. The next one is I'm going to have nickel plus 2. I'm going to add ammonia to it, excess concentrated ammonia to it, and I'm going to get nickel with the ammonia. Let's look at the charge on the nickel. It's plus 2, so how many ammonias do I need? I need 4. I'm going to balance that by putting 4 right there. Let's add up my charges. The nickel has plus 2. The ammonia has 0. So I'm going to end with plus 2. And the last reaction I have is iron plus 3. Plus I have cyanide, Cn minus. That's our ligand here, our excess concentrated. Our iron is going to come together with our cyanide. Look at my charge on my iron. It's plus 3. So how many cyanides do I need? I need 6. And I just need 6 right there. Let's add up my charges. Plus 3, -6, -3. That's all my reactions, guys. That's the sum of all my reactions. Make sure you know them, practice them, and ask me if you have any questions. All right? See ya. Bye.